Hi, everyone. Welcome to today's webinar. We're just going to wait a couple minutes until everyone gets to sign up and log in. All right.
Hello, everyone.
So people are logging in quite fast. We have 17, 19, 21, 24, 26.
Excellent.
It's going up exponentially, Bob.
Perfect. Perfecto.
We're set for the crowd today.
Nice.
Super interesting topic today, talking about the origins of Antarctica.
How's things in Chile?
So it actually looks like it's transitioning finally into fall over here. So it's
Into fall, nice.
Yeah, it's pretty nice.
Getting some colors.
Yeah, the leaves are falling, and yeah, it's a nice time of the year.
I love the change of the seasons. It's beautiful.
Yeah. How about in Washington? I believe we are in pretty much opposites of the hemisphere. You know,
We
California, Washington.
Spring is just coming into full swing here. It's beautiful. All the flowers are budding and the trees are coming out. Yeah, it's gorgeous.
We've had some
really warm weather. Sorry, go ahead. I apologize.
Oh, no, go ahead, please, Bob. I just wanted to mention, to ask everyone where are they joining us from today? Where is our crowd from? You can go to the Q&A or the chat just below in the screen and let us know.
That'd be interesting to see where everyone's from.
Scotland, Texas, Canada, Ontario, Nashville, nice. Spain.
Wow.
We have someone from Chile as well. Italy, Russia.
Wow.
North Chilean one. California. Bath, England, the UK. Well, we have an international crowd today. Seattle, look, that one's close to you.
Seattle.
Hey. Yeah. You're in Anacortes, right?
I'm in Anacortes.
You had lunch in Seattle today, or are you going to have lunch
today?
No,
I can go have lunch with that person from Seattle.
Oh, David Hartnett, yeah.
David.
That's quite the crowd for today. All right. So I think we can wait another minute and let's get started.
Yeah, let's let people, let's get people in and logged in.
I'm sure the alarms are going off on the phones, reminders, webinar day.
Right.
On Earth Day, yeah.
Right.
Yeah, it's Earth Day today, actually.
It is.
Yeah.
Beautiful day.
The anniversary of the modern environmental movement.
That's right.
Always an interesting day for us working in the tourism industry. We also have some people from New York City, from Argentina, London.
London, wow.
And we're still going up. I think we're gonna probably go around 50 attendees today, maybe even more.
Nice. Well, I'm excited, Renato. How about yourself? This is fantastic.
I know we've been talking about this for, some weeks now, but until the actual day, there's always some jitters. So yeah, I'm excited to start, to see what people think.
Yeah, and these are subject areas where I could go on for hours and hours and
Probably.
hours. I have to condense everything down, but
not an easy task for sure.
That's what you get when you come on the ships. You get a lot of details.
Exactly. You get this every day.
Yeah.
People like Bob giving super interesting lectures on, the history, the geography, geology, wildlife, etc. You name it.
Absolutely. We'll focus in very well every day, answering all your questions, because there's always a lot of them. Because Antarctica is a mystery, and we're going to go discover it together.
All right. So I think we're safe to say that we could start. So why don't we go and do that, Bob?
All right.
All right. So good afternoon, everyone, or good morning, good evening, wherever you're right now, and happy Earth Day. My name is Renato Marin, and I am the Sales and Marketing Manager here at Antarctica 21. And I am here today with Bob Gilmore, Senior Guide and expert on Antarctica. Bob's gonna talk us today about the mysteries of Antarctica and how it came to be. So in case like you might have heard us, we're doing this remotely. Myself, I am in Santiago, Chile, and Bob is in the beautiful state of Washington in the Pacific Northwest. So if there are any technical difficulties, please bear with us. As a reminder, this webinar is going to be recorded. So if you miss anything, don't worry about it. You will receive a recorded webcast in the follow-up email. Also, one lucky participant today will go away with a must-do expedition jacket, similar to the ones that we offer in our trips. So sit tight until the end. And last but not least, everybody's a winner today, because we will be giving a 5% discount to everyone who register on all of our 2022-2023 trips. So stay tuned for that in the follow-up email as well. Do remember to send us your questions through the Q&A box down here, and we will be answering them after this presentation. But before we get started, A21 is all about air cruises to Antarctica, where we offer boutique-style wilderness adventures for explorers like yourself. And now, without further ado, Bob, I'm gonna let you take it from here. Please go ahead.
Thank you, sir. Thank you. Hello, everyone. Chiming in from the Pacific Northwest, Anacortes, Washington, just north of Seattle. As Renato said, good morning, good evening, good afternoon, wherever you may be coming from. And today, it's Earth Day. Happy Earth Day, everyone. And what a better way to celebrate Earth Day than discovering the mysteries of the Antarctic continent. And that is what it was for almost the entire existence of human race on this planet. Antarctica was a complete mystery because we physically couldn't get down there. The Greek philosophers theorized, since there was an Arctos, there must be an Antarctos. And it wasn't until very recently, honestly, until the 1700s, where we had ships. Let me just give you a brief synopsis. This is the southern tip of South America. That is the Drake Passage. This is the Antarctic Peninsula. During the early shipping days, we didn't have the Panama Canal, and they had to go around Cape Horn. And the Drake Passage is known for being some of the most incredible weather on the planet. And every so often, a ship would be blown off course. And one time, one was blown off course, and they saw white land in front of them, and they were like, what is this? And that's when they discovered the Antarctic continent. And they went back and told all their friends, and sure enough, they started coming down in droves. And we'll get to that a little bit in a moment. But it's been a mystery for, like I said, almost the entire existence. And before I jump in, I just want to give you a brief look at what this is. Obviously, a satellite imagery of the Antarctic southern continent. And all of the bright white you see here, this is glacial ice. This is the continent itself. And then all this grayer white area or surrounding the continent is actually sea ice. So glacier ice is land-based ice, freshwater-based, and sea ice is marine-based ice. And this photo, this satellite image, was most likely taken in springtime when the sun returned, and we still had all that sea ice around the Antarctic continent. Looking specifically at the continent, it is divided by the Trans-Antarctic Mountain Range, located right through here. And it separates West Antarctic ice sheet, which the Antarctic Peninsula is a portion of, by the East Antarctic ice sheet, the much larger East Antarctic ice sheet. And Antarctica, once we discovered and started unveiling the mysteries of the Antarctic continent, we found that it was full of superlatives. It's the highest, it's the driest, it's the coldest, the windiest, the most remote and inhospitable continent on the entire planet. So why don't we all jump on an aircraft and go take a look, huh? Come on down with Antarctica 21 and we'll show you up close and personal. Yeah, look at this. This is a horizontal view of the entire continent, and you can see the elevation on the left here in meters. As you think, maybe South Pole Station, the geographic South Pole would be the highest. Not so. It's in the middle of the Eastern Antarctic ice sheet at Vostok Station, and that's the Russian station. We're there at about 15,000 feet, or roughly 5,000 meters, and it is flat as a pancake, but it averages about 1 mile in thickness around the entire continent. So it's the highest continent on the planet. It's also the driest. It's considered a desert, yet holds 70% of all the fresh water on the planet locked up in glacial ice. What an interesting concept that is, huh? It's also the coldest, actually the windiest. We'll go with that first. 320 kilometers an hour recorded, sustained winds up to 200 miles an hour as well. Absolutely the windiest continent on the planet. And here we go with the coldest, negative 89 degrees Celsius or negative 128 degrees Fahrenheit. If you're trying to crack a few eggs on a pan, you better be quick about it. Or maybe even some spaghetti. Look at that one. Frozen salad in seconds. It's so cold down there. However, do not fear. Those temperatures and winds were recorded in the interior of the Antarctic, not on the peninsula. And this is where we're going to be focusing our journeys and expeditions right here on the Antarctic Peninsula. It's the furthest north, and the further north you go, the warmer it gets. You're going to be flying into this island right here, King George Island, and then we'll be setting course for the Western Antarctic Peninsula and exploring all these beautiful fjord systems. And something I'd like to incorporate here is scale. You may think we're not seeing the rest of the continent, but I'm telling you right now, you'll be seeing quite enough. Your jaws will be on the ground. This is a quick footage of some drone footage. I apologize if it's coming across a little choppy, but the idea. This little speck right here in the middle down there is a Zodiac full of passengers, and you can start to see the scale. This is in a very small channel called the Arera Channel with an island, believe it or not, right in front of us called Cooperville, which is one of our destinations. There's the Hebridean Sky, one of our ships. You can look at scale now. Now you're looking west across the Gurlas Strait towards Anvers Island. And on top of that, we have Mount Francais, which is the largest island, the highest mountain in the peninsula region, which is 2,700 meters or 9,000 feet. So you're going from sea level to 9,000 feet. There are proper mountains on the peninsula. And these cliff faces, 90 feet off the water's edge or 30 meters. Scale is immense down in the Antarctic. Beautiful. To further that, look at this scale. This is the continental United States as compared to the Antarctic continent. The Antarctic continent is massive. Here's Australia. Antarctica is bigger. What about the entire European Union? Antarctica is much larger. Incredible. So to the question, one of the biggest mysteries of the Antarctic continent is how did it come to be? How did it form? And to do that, we have to dive into one of the elements of our educational curriculum on board, and that is the abiotic portion. This is how we're going to answer that question. If you don't know what abiotic means, it's basically the inorganic side of the ecosystem, the non-living. It's the rocks, it's the water, it's light, it's wind, things like that. But within our philosophy, we tell the story of the Antarctic continent. Our philosophy is based on connections and how everything is connected around this planet. And the abiotic is directly connected to the biotic, and that's when we'll start talking about the penguins and the whales, etc. And then the biotic portion of the ecosystem is directly connected to the human element as we discovered the continent and brought on the heroic age. And then, of course, inquiries, minds want to know. That's what brought up science, and then form the Antarctic Treaty, We wanted to keep this place pristine. And then through that science, we started looking into further, and then found that things are changing, bringing things full circle to today. And we'll get into a little bit more about that later in our talk. And I digress a little bit. Let's get back to our main question and discovering the mysteries of how Antarctica came to be. And to do that, we actually have to dive deep within the Earth. We have to go into the core and realize how hot the inner core, outer core, and mantles are. And we're going to go to one simple law of physics, and that is that heat rises. Okay, we're talking, we're going to how Antarctica came to be, and we're talking about heat rising within the Earth, because as we have this upwelling, things get cool down as it hits the underside of the continental crust. It cools, it actually sinks again and remoltens, gets warm, upwells again, creating what's known as convection currents and convection cells. And this, over geological time, moved the continents across the globe. And there's different plate boundaries. I'm just going to hit those real quick. They either move next to each other, away from each other, or towards each other. And when they're moving towards each other, a lot of times you have continental crust that subducts. You have a less dense oceanic crust than continental crust. It subducts, sinks, remoltens, and causes volcanic eruptions. And that's how the Antarctic Peninsula came to be, through volcanoes and igneous rock formations. So this is where the abiotic is taking in charge about how the creation of the Antarctic continent came to be. And when we're looking at plate tectonics, we have to go back in time. Let's go back to the Jurassic, 152 million years ago, where Antarctica was attached to Australia, India. Look where India was, Africa, and South America. Let's move forward in time, 94 million years ago. The South Atlantic was born. South America and Africa have detached. India is heading north, and Australia, Antarctica, and the southern tip of South America are still attached at this point in time. And at this time, Antarctica was fully forested. We have petrified forests. We have all kinds of fossil evidence, but you have to remember that only 2% of Antarctica is exposed. The rest, 98%, is covered with glacial ice. So it's a bit hard for archaeologists to get down and really see these things. It was 66 million years ago when the South American continent detached through the Scotia Plate, but Australia at this time was still attached. Antarctica was at the pole at this time. There were glaciers starting to form, but not until about 60 million years ago. I know this says 50, but 60 million years ago, Australia finally detached, creating the Southern Ocean, further isolating the Antarctic continent from the rest of the world. It was already at the poles, and it didn't take long before all this glacial ice began to form. And how do glaciers form? Well, it's a very, very simple process as well. It's simply snow falling in the summertime or the wintertime that doesn't ever melt. And when you're a continent at the poles, there's not a whole lot of melting going on, and it turns into granular snow, into what we call firn, and finally into glacial ice, where there it accumulates over millions of years. And it didn't take long for the Antarctic continent to become fully engulfed in glacial ice. Really remarkable. And if you think all this glacial ice is static, you're wrong. It's not. It's constantly moving from the interior to the exterior. Those areas in red are just faster moving pieces of ice, pieces of glacial ice. And this is a great animation to show you how it moves from the interior to the exterior at all times. It's constantly moving, but it's over an expanse of thousands of years. And you can see this in some of the alpine glaciers around the planet. You can see this is not in Antarctica. This is from the Alps, but I just wanted to show you that these are just like rivers, these alpine glaciers, and these glaciers do move over time. And this is time lapse over several seasons. When these massive glacial ice sheets reach the continental margins, they succumb to tidal flows, and they break up and float away as icebergs. And that's my next subject area in the abiotic realm, uncovering the mysteries of icebergs, because icebergs are one of my favorite things down there. There's no two alike. And when we're seeing them on top of the water, we're only seeing 10%. 90% of these icebergs are underneath the water. And they all have the mystery of themselves. And if you get to be able to read these, learn how to read these icebergs, you can tell their history. And I'll give you a quick history right now, quick lesson. You can see at the top of this iceberg, all this chiseling coming on right here. Well, this is telling us that this is a fresh calving. That's where a piece broke off. And what happens when a piece breaks off an iceberg, the buoyancy changes. So what was underwater becomes above water, and we can see it. And this is evidence that these areas were all underwater before, because this is used to be the water line at one time. This is where the water line was, which is right here, right now. But you can see these other two horizontal lines. This is the water line. This is successive calving events that cause these to break up and rebuoyance. And then these vertical lines here, how are they formed? Well, you have to think again how glaciers are formed, and it's through snowflakes. And when snowflakes get compact, they sometimes hold air pockets. And when these glaciers start to melt, these air pockets are released as bubbles. They float to the surface. They start forming these channels, and we call these bubble channels. Really amazing. Another really interesting thing about these icebergs is they form these beautiful archways. And this just happened to be a piece of less dense ice than the rest of the glacier. So it calved out first, creating these beautiful, beautiful sculptures. And again, scale. If you look over to the right here, we got a couple hitchhikers. Look at all these penguins over here taking a ride, taking a break, really. They just come up on top and take a break, socialize for a little bit. Hey, where are you going? Well, I'm going to go eat some krill. Okay, I found some over here. Well, let's keep rolling. We came around in a Zodiac, and these are the types of things that you'll be seeing too. We'll be seeing all these types of icebergs. We came around in the Zodiac, and wow, look at that. It looks like the Roman Colosseum, but now that we know how to read these a little bit, we're starting to uncover the mysteries here. And we can see these horizontal lines, or that used to be the water line at one time. A piece calved off, the buoyancy changed, and all what was underwater is now above. And these vertical striations, bubbles, simplicity of physics, bubbles moving to the surface, rising to the surface, creating these channels. Just amazing. And then another thing, a last thing that we want to talk about within the realm of icebergs down there, freshwater ice, is the density factor. And you can see this white one in the background, this blue one here, and this crystalline here. Well, when you have a less dense ice, there's going to be more air pockets, and then it scatters the light like a fresh snow on the ground. It's going to come out as white. When it's deeper in the glacier itself, it's more compact. We're going to see those as darker blue. But the oldest ice that we're going to see is coming from the bottom of the glacier. You're going to see those as crystal clear. We love to pick those up and bring them into the Zodiac to show you. They're awesome photogenically, but also they're some of the oldest pieces of ice on the peninsula, ranging in age from 20 to 30,000 year old ice, since 20 to 30,000 years since it fell as a snowflake. Really remarkable. Sometimes we'll bring it back on the ship to show other Zodiac members, other members of the passengers that didn't maybe come across it. And then if you're really lucky, someone might bring it into the bar because it's some of the most pristine ice that you'll ever find on the planet, and we can make 30,000 year old gin and tonics or Coca-Colas or whatever you're into. Something special you can only find in the Antarctic. So this is another view you might be able to see in the Antarctic if you get down early enough or you get down south far enough. And this is sea ice. In the distance, you can see that is an iceberg. That's glacial ice, but all this horizontal flats ice, this is all frozen ocean. This is totally different animal than glacial ice. This is formed maritime from salt water, freezes every winter. It's really amazing stuff. We hope to be able to see that every year on our missions. Sometimes we're a little too far north, but sometimes we get lucky. And I want to show you this animation of how sea ice forms seasonally. We're coming into winter now, and you can see how large sea ice expansion is. It's almost 68 million square kilometers. And now we're coming into summer in Antarctica. You can see all the sea ice melting. We have some residual areas in the Weddell and Ross Sea. And then we're coming back into winter, and you can see how the sea ice formation is growing and growing and growing. And there's something really magical that happens on the local level, but even on a global level. And we're talking about how everything is connected. Let's talk about this real quick. And this is just a profile image of the circumpolar current, but you can see here over on the right, upper right side, this is sea ice forming. And sea ice is formed from ocean water, from seawater, which is 34 parts per 1,000 salt. But when the ice itself forms, it doesn't have room in the molecular level to be able to hold the salt. So it's actually, if you look down here, all that salt is rejected. Think about how much salt is being rejected when we have almost the doubling of the continent in size and sea ice forming each year. That's a lot of salt. And what that does, again, simplicity of physics, it creates a really dense, cold water current that drops immediately to the bottom of the ocean. And that drop, that physics right there, is what makes for one of the major oceanic currents, the deep water currents. And you can see this one, this is the North Atlantic deep water current coming in from the Arctic, comes all the way down the Atlantic and joins in on the circumpolar current in the Antarctic. The Antarctic circumpolar current then gets sometimes detracted out by underwater topography and then upwells in areas like the Indian Ocean. And I want to just concentrate right there very quickly on this one. We can see the deep water cold currents in green. The yellow are the surface warm water currents. And you can see this one right here deflecting off into the Indian Ocean and then upwelling. Something magical happens again, and how everything is connected, that when you have deep, and first of all, with cold water currents, you have high oxygen content. And when you have high oxygen content and deep water currents, you're also carrying nutrients to these areas, to this ocean. So it feeds the Indian Ocean at the equator. It feeds the ecosystems there. So we as a species benefit from that, from the molecular level all the way to the big fishery species that we harvest for food on our plates and every day. Something else that happens at the equator when you have cold water currents upwelling to the surface, you have evaporation. And we have huge evaporation going on at the equator. You also have air currents that push that moisture-laden air currents over continental land margins, and they falls in the form of rain, and that's what causes is not fully, but it is essential in the monsoonal rainfall of India. It's a major contribution of, and thinking about how things are connected, what's the major agricultural crop in India? Rice. So when you have monsoonal rainfall, you have healthy, happy people in India and many others. And we can probably go on, as I'm saying, I can go on and on and on, how we are influenced, how everything is connected from down in our polar regions. Very, very important on this Earth Day. So next, I wanted to just talk about the abiotic. We're talking about that and how it's connected to the biotic realm and how everything else is connected within our entire Earth. And science in the Antarctic Treaty, and as science has been developing over time, we've started noticing things about how things are changing in the Antarctic, around the world too, but specifically we're talking about the Antarctic. And we, with Antarctica 21, have partnered up with scientists from all over the planet to help them unravel the mysteries that they're starting to see. And if you're a scientist, trying to get to the Antarctic is not easy. You have to apply for grants. You have to charter a ship. You got to bring your colleagues. You got to bring all your equipment. It turns into a multi-million-dollar effort where you can only get down there, and usually you have a window of about 1 month. Well, we in the tourism industry, Antarctica 21 says, we're there for 5 months out of the year. We could help. We could help you guys in some way. So we got together with them, and we've introduced, it's in a trial run right now, but a citizen science program to where you as a passenger can come down and join in, participate in some science to try to figure out and help the scientists what's going on. So citizen science, let me give you a quick intro to that. The Antarctic Peninsula, as you can see here, is one of the fastest warming areas on our planet. We're kind of shocked at what's going on there. We have a lot of interested parties, including National Science Foundation, NASA, the Scripps Institution of Oceanography, and we go to shore every day when weather allows. We try to, it's a priority, plan A, and sometimes we go to plan B. But plan A is to go to shore. Sometimes we're gonna go check out a Gen 2 penguin colony. And after you're done with taking your beautiful photographs that you share with all your friends, we might be able to say, hey, anybody interested at this time This is Snowy, one of our senior guides as well. He's going to be doing a penguin survey, and scientists are worried about phenology, and that has to do with their reproduction cycle. They're thinking that the penguins might be coming down earlier and earlier each year because things are getting warmer. Another thing is called happy whale, and they're studying the migratory routes of whales, and it's very simple to join in on this. All you need is a camera. I think everybody brings a camera and get a fluke shot. Happy Whale has made an algorithm where they can identify each individual whale by the bottom of its fluke, just like a fingerprint of one of us. And we can get evidence of things like this. This is really amazing. This is whale whale AHWC 4116 was photographed off the Antarctic Peninsula here, and then photographed again, I believe this is Tonga, but it was almost 9,000 kilometers one-way migratory route. Unbelievable. These creatures are beautiful. Help us figure it all out. Who wants to work for NASA? I know I do. I have. It's fantastic. They have a cloud program. Look at that cloud right there. That's called a lenticular cloud. They're interested on how clouds are affecting people on your phone and connect away. So that's NASA. And then finally, one of my favorite citizen science programs is called Fjord Phyto, and that's with the Scripps Institution of Oceanography. And they study these little guys, phytoplankton, single-celled organisms. They photosynthesize, they're drifters, but they're essential. Their biomass is larger than the human biomass in the Southern Ocean. It's unbelievable. And everything eats them. This little guy over here is what's called krill. And you can see right in the stomach of a krill, all the phytoplankton. And what I meant to say a moment ago is everything eats krill right down the whole food chain, all the way to the charismatic megafauna. And what we're seeing is we're seeing these ecosystems change. And what we're seeing is glaciers melting much quicker. And with that meltwater, remember, it's fresh water, it's formed from snow. So we're seeing more fresh water enter the saline environment of the fjord systems. What we're thinking is that might change the phytoplankton, either in numbers or types, and that could influence the krill population. And if it influences the krill population, it could influence the rest of the entire ecosystem. That's the penguins, the seals, the whales, everything. So it's really an important citizen science program. And like here, everyone can be involved. Somebody can be using the net overboard. Someone can be using this, it's called the castaway. It gets a vertical profile of the water column. And everyone gets involved. It's fantastic. You can be a scientist too, and that's our citizen science program. And with that, I'll conclude this portion of discovering the mysteries of Antarctica. I highly recommend everybody coming on down and join us because there's so much more to discover. And with that, I'll hand it back over to Senor Renato. Thank you, everyone.
Thank you, Bob. It was a wonderful presentation, and not only the origin of Antarctica, but also how important a role it plays in our day-to-day life, whether we care to admit it or not. And I think it's only an appetizer of what people will be hearing and taking part in one of our trips. So yeah, by all means, come on. All right. So like I mentioned in the beginning of this webinar, we operate air cruises in Antarctica. But what is that? So our model, which we pioneered, basically combines a 2-hour flight from Punta Arenas in Chilean Patagonia to King George Island in Antarctica. This saves you roughly 2 days of sailing through the stormy Great Passage, like you mentioned, and allows you to spend, not only get there faster, but spend more time on location. That's why you came to do. We have 4 itineraries that go to Antarctica, starting with the Antarctic Express Air Cruise, our shortest trip that combines a sailing leg with a flight back to the continent, or the other way around if you're doing the reverse itinerary. And this is an introductory and affordable expedition experience. Our most popular itinerary is the Classic Antarctica. that offers a complete Antarctic experience, including round-trip flights from Punta Arenas to King George Island. For those of you with the time available and the need or the desire to reach the Antarctic Circle, we have the Polar Circle Air Cruise, which is basically the same itinerary as the Classic, just a couple days longer. And finally, we have the Antarctica and South Georgia Air Cruise, and that is our longest trip. And it also combines two of the most amazing bucket list destinations. This is really a trip like no other. And we do all of these trips in 3 of our ships. First of all, we have the Magellan Explorer, our newest and most modern expedition vessel that was custom built here in Chile for our air cruises. We also have the Hebridean Sky, which offers a classically elegant base for adventurous exploration. And finally, we have the Ocean Nova, a sturdy and nimble expedition vessel, and actually one of the 2 ships that will take you to the Antarctic Circle. All right, and that's all the info on our trips. I don't want you to overburden you with information. We will follow up with more of that on our follow-up email with early booking benefits and other discounts on our trips for the next season. And now it's time to answer your questions. So let's go through the chat to see what we have. All right. So first one, I think you can answer this one, Bob. How can you join the Citizens Sign program as a traveler? Is it offered on all departures? I think you froze there, Bob. Well, in the meantime, while Bob comes back, I'm going to answer that question for him. So yes, citizen science programs are offered on all of our departures, and you're free to join on whatever trip that you're choosing, either the Antarctic Express, the Classic Antarctica, or the Polar Circle, and even so in the Antarctic and South Georgia trip. So that's available for all of you. Next one, and I think for this one, we will wait for Bob to come back.
I think I'm back.
Oh, you're back. No worries,
Sorry
Bob.
about that.
That's okay.
Technical
We informed you in the beginning that this might happen, so no worries. I was just
citizen science question. You want me to just jump back into that? Yeah.
I feel them on that, but we could use your perspective as well.
Yeah, so we'll try to get that on every itinerary. It's a new program, so depends on what ship and what time, but we're going to try to get that on every ship this next season.
Yeah, all right. And next one, before Antarctica broke off into its own continent, were there trees and plants that covered the continent?
Absolutely. There's evidence of petrified forest in the exposed rock formations in around the Antarctic, especially in the Transantarctic mountain range, which is in the interior. Not so much on the Antarctic Peninsula that we've seen so far. It's all volcanic and relatively young geologically. But yes, Antarctica definitely has fossil evidence, even of dinosaurs.
All right, then. On to the next one. And this one says, how old is the ice and icebergs on Antarctica?
Very, very, very good question. They've done ice core drilling at the highest points in the Antarctic, and that's out at Vostok Station in the middle of the eastern Antarctic ice sheet. And they can drill down, and it goes right back like a tree ring, because the earliest stuff is the snow that's on top. And you go, the further down in depth you go, the back further in time you go. And they can go back 800,000 years.
Wow.
In some of this ice formation. And just recently, in the Allen Hills near the Transantarctic Mountains, they found some ice that was over 1 million years old. So it's fantastic. It's really, and they're discovering more mysteries and more mysteries all the time. And then some of the icebergs that we'll be seeing on the peninsula itself, the ice there is going to be 20 to 30,000 years old. And you have to look at the fact that the peninsula doesn't form those incredibly large ice sheets like the interior of the continent does. So it's going to be younger in age.
All right. Okay, and a slightly different question. When is the best time to see fauna, wildlife?
That's a question we get all the time. When's the best time to go? The best time to see fauna, wildlife, anytime in the summer in Antarctica. Whenever we're offering trips to the Antarctic, you'll be able to see wildlife then. Now, what species of wildlife? It differs throughout the season. You're going to have the whales more in the latter part of the season because it takes time for them to migrate down to the Antarctic and start feeding. You're going to have penguins right off the bat. They're going to be coming in, and at the beginning of the season, the penguins are going to be courting and then mating, then building their nests, which is really comical to watch them gather stones and steal stones, etc. But you'll be able to see fauna, wildlife throughout the entire season.
All right. And I think that's all the questions for the time being. Now, and that's also all on my side, but we have one last question. Let's take this one first. Which Antarctic specialists do you have on board?
Which Antarctic specialists? We have quite a few. We have historians, we have ornithologists, bird people, we have marine mammals specialists, we have geologists, glaciologists, all types, to give you a well-rounded educational experience for sure.
Oh yeah, that's a very varied offer that we do. All right, and let's pick a couple more. I just got some more.
Sure.
What is the weather and temperature like in Antarctica? What should I pack to prepare for it?
That's a very good question, considering Antarctica is one of the windiest and coldest on the planet. On the peninsula, however, it's much more mild. We're much further north. We're there in the summertime. Temperatures there, you can get by in what you go skiing in. The temperatures are going to be in the single digits Celsius wise. Usually it's going to be above freezing, unless you're there in the early part of the season or the latter part of the season. Then you're going to dip down below freezing, but it's going to be mid 30s to 40ish on a sunny day. I've actually walked around on hikes in my t-shirt. I do it a lot when the sun's out and there's no wind, so it's not that bad at all.
Exactly. And you mentioned a season. There's someone asking about if we can visit Antarctica all year round, but that would be a no because our season actually.
Yeah, the winter season, the whole ocean that you see in front of you right now is all locked up in sea ice. We can't even get in.
Exactly. All right. And regarding that, we do offer landings in the Antarctic Peninsula, right?
Say that one more time. What was the question?
Do you offer landings in the Antarctic Peninsula?
Do we offer landings in the Antarctic Peninsula? Absolutely, every day. That's plan A, is to get off the ship and land somewhere. And if we can't physically land somewhere, our next option is to get on Zodiacs and go for a Zodiac cruise and go find some wildlife. Definitely.
All right. And the last one, and I think this is very related to your presentation actually. Someone is asking, why should I visit Antarctica?
Why should you visit Antarctica? Well, how much time do you have?
That's right.
Antarctica is like visiting another planet without leaving this one. It'll change your life. This will be my 21st season visiting the Antarctic, working down there, and I'm excited. And we're not even close to going down yet for the season. My jaw is on the ground every time. It's mind blowing. It'll change your life. Come on down. We'll show you.
All right. Okay. So unfortunately, we don't have too much more time to answer all of your questions, but the questions that didn't get answered during this webinar will be answered in the follow-up email. All right. And like I mentioned in the beginning of the presentation, we are giving away a Master Expedition jacket today. And now it's time to announce the winner. So drum roll, please. The winner is Andrew Lewis from the USA.
Andrew,
actually.
Nice.
Congratulations on your jacket. Yeah, we hope you get to use it in Antarctica.
Awesome.
So we will be getting in touch with you via email to coordinate the delivery of your jacket. So yeah, make sure to check your email later today.
Nice. And congratulations.
Congratulations, yes. All right, and that is the wrap for today. Thank you, to everyone joining and attending today's webinar. Thank you, Bob, for a wonderful presentation on the origins and mysteries. Let's
you,
hope
Antarctica
to do
21.
this again sometime. And if you want to reach us out, don't hesitate to write us to our sales email or to my personal email that you can see in the following slide. And I look forward to talking to you and and your friends and family soon. Have an awesome rest of your day.
Excellent. Thank you, everyone.
Bye bye.